Hello everyone, this is Jeeva Abishake from AIML department, and I am here to do a presentation on a topic of mathematics behind linear regression. So first slide will be, what is machine learning? Machine learning is a study of algorithm that improves its performance by previous experience by doing some task. So it can predict accurate and precise output. So that is what machine learning algorithm does. So next will be a linear regression. Linear regression is a statistical procedure that predict a dependent variable with some influencing independent variables, which is x and y in this case. So we can derive to the linear equation, that is y is equal to mx plus b. So here y is a dependent variable and x is an independent variable. So for more clear, we can see the example of simple linear regression and multiple linear regression. So in simple linear regression, a person's salary can be influenced or depend on a factor of one, or it can be multiple factors which influence the person's income. So that is what the multiple linear regression and a simple linear regression. So here, the time, the working hour of a person is a only factor that influences the income of a person. So this is called simple linear regression. What is multilinear regression is different factors like his graduation and his working experience. And multilinear regression is what more number of independent variable which influences the dependent variable. Our next slide will be mathematical approach towards linear regression. So by machine learning or by training a machine learning algorithm, we can predict or precisely predict a dependent variable. So here the H is a hypothesis. By creating an algorithm and training it with data sets, we can predict a dependent variable. So here the main task is to frame a hypothesis. This is what we are doing in a machine learning algorithm. Here we can see an example that here we can see the example of price of the house, which influences by area. So if area increases, the price definitely would be increased. So this is graphical representation of previous data set that we had in a previous slide. So now our main task is to predict the price of a new house using this data set. This is achieved using linear regression. What we do is fit a line into our data set in such a way that is minimize the distance from each points. One prediction would be above blue line or below blue line. So note that I have tried to draw the line in such a way that it could close relative to all the points. So we have to choose such a line that perfectly fit our data. Whenever I enter the area of a new house, it will automatically tell the price of the house using this line. I entered area is equal to 30. So 30 is between 20 to 40. So we can predict the approximate rate of the house. It's predicted the price of house that is $95 or about its range, which according to our data set is reasonable price. So mathematical approach towards linear regression extends towards hypothesis function. Hypothesis function for a linear regression. While training a model, we are given with x and y. X is input and y is labels to data. When training the model, it fits the best line to predict the value of y for a given value of x. The model gets the best regression fit line by finding the best theta 1 and theta 2 values. Once we find the best theta 1, theta 2 values, we get the best fit line. So when we are finally using our model for predicting, it will predict the value of y for the input value of x. How to update theta 1 and theta 2 values to get the best fit line? So here comes the cast function. By achieving the best fit regression line, the model aims to predict y value such that error difference between predicted value and true value is minimum. So it is very important to update the theta 1 and theta 2 values to reach the best value that minimize the error between predicted y value and the true y value. So cast function of linear regression is the root mean squared between predicted y values and true y values. Cost function. Here's gradient descent. To update theta 1 and theta 2 values in order to reduce cost function and achieving the best fit line, the model uses gradient descent. The idea is to start with the random theta 1 and theta 2 values and then iteratively updating it. Squared error cost function. At this stage of our primary goal is to minimize the difference between the line and each point. This is done by changing the values of slope of the line, which is theta 1, and y-intercept theta naught of the line. So we have to find theta naught and theta 1 for which the line has the smallest error. The line shows the distance of each point from the line. When we sum up the difference for all the points, it gives us the error in the line. So we have to minimize the error to gain an optimal solution. What we can do is move a line a little bit higher, lower, change the angle by changing the values of theta 1 and theta naught. To achieve this, we will use dummy values of theta naught and theta 1. Put this in our hypothesis function and calculate the cost of that line. Repeat this step until it reaches the minimum cost. Previous slide, we saw that we have to minimize the error to get optimum solution. So what do I mean by minimum error? Let us consider the above prediction. X is the input variable, which is area, and yi is the output variable, which is price in the table. So M is the number of training examples. Now come back to our line and error function. To understand the cost function, we have to take a help from calculus. Consider the graph again. Let us try to calculate the cost of for each point and the line manually. So we are subtracting each point from the line. The point on the line that is precisely below the specific point can be found by putting the value of x in the line equation. Now sum up all the terms using the summation sigma. The limit for the values to be summed is equal to the number of points. And each point refers to a particular training example. So our I varies from 1 to m. Now exchange the position of the y and hypothesis function, which is h, and take square of account for the negative values. Divide the summation by 2m to reduce the cost. This is just to make computation easy for the computer. So measure the performance of the regression model. To measure the performance of your regression model, some statistical matrix are used, which is mean absolute error, root mean square error, coefficient of determination or R square, adjacent R square. A good regression model is one which the difference between the actual or observed values and predicted value for a selected model is small and unbiased for training. Validation and test data set. The performance of a regression model can be understood by knowing the error rate of the prediction made by the model. So, thank you. Hope you understand the linear regression and mathematics behind linear regression.